Hey all! So in this lesson, we're gonna combine concentration and pH. Now, what does that mean? Such as, if you have a certain acid with a certain pH, you have an acid with a certain pH. If you add water to it, what happens to the pH? On contrary, if you have, let's say, some sort of base, and you add it more base, what will eventually happen to the pH? And at the very end, we'll finally take a look at a question where if somebody asks you, hey, I got this solution of acid, pH is 1. Can you make that 1.5? What are you going to do? So these are the type of questions that we're going to try to solve here today. All right, let's take a look at some examples from these questions, and we'll start from there. So example 1, you have 50 milliliter of water is added to 150 milliliter of 0.6 molarity of HCl. Now that's an acid. Calculate the pH. A, before water is added. B, after water is added. Okay, so in this question, let me just draw exactly what they are trying to say. So you have a beaker, and in this beaker you have HCl, you have hydrochloric acids. It is 0.6 in molarity, and it is 150 milliliter. Okay, so they want to know, before you add this in, what is the pH? All right, let's take a look. So HCl plus water is going to give you H3O plus and Cl minus. Now we've seen that already. We know about this. So if HCl is 0.6 molar, H3O will also be 0.6 molar. Now, the reason is very simple. The ratio here is 1 to 1. It's always going to be like that when it comes to acid, because when it comes to acid, the acid and the hydronium is always the same in terms of molarity, so no need to stress. Now, why is this important? It's because the definition for pH is -1 times log of H3O plus. That's why. So all we need to do right here is to sub in 0.6, and you should have an answer of 0.22. So that is the pH of this solution before you add water. So let's take a look at part B, because part B, we are saying we're going to take 50 milliliters of water, and we are going to dump it in here. Now, before we begin, let's take a look at some predictions. So if we are adding water to an already existing solution, what's happening is that we are diluting it. All right. By diluting, the concentration here will lower. Now, how much lower? We'll calculate that. If this is an acid, which it is, a lower concentration will raise the pH. So our prediction is the pH after adding in 50 milliliters of water will increase. All right, let's check it out. Let's see if that is right. So let's solve this. Since you are adding water, you are diluting. So the first thing you should think of is dilution equation. The original concentration is 0.6 moles per liter. Original volume is 0.15 liter. Yes, I converted milliliters to liter. And I want to know what is the final concentration, and the final volume here is that you're going to take 0.15 liter plus 0.05 liters, because that's how much you're going to add. So C2, it's going to be 0.45 molarity. Hey, just like what we predicted, by adding water, the overall concentration right here will decrease because you're diluting. No kidding. All right. Hey, using the same idea here, we can find pH to be negative log of 0.45, and your answer should be 0.35. Does it make sense? Well, pH went up. You're, less concentrated, so it's not surprising that it's less acidic. So hopefully you understand exactly how pH changes here when you are adding water, making it more diluted and stuff like that. Let's take a look at a second example. This one, hey, well, we're talking about a base. So again, let's draw the situation here. What is happening? So you have a beaker of water. 2.5 liters of it. And you're going to add 25 grams of this stuff called magnesium hydroxide. It's a metal hydroxide, so we know this is a base. What do base do? Well, MgOH2 dissociate to give you Mg2 plus and OH minus. Now, you have to be very careful here, because when you balance it, you should have a 2 here. Meaning that the ratio between MgOH2 and OH is not 1 to 1, but is 1 to 2. For every 1 mole of this, you can make 2 moles of this. Now that's a very important concept which we will take a look at very soon. So, first, we want to find the pH of this solution. Well, before we find pH, we need to know what is the concentration of MgOH2. So concentration is equal to the mole of MgOH2 divided by the volume. Now, volume is 2.5 liters. We know that. What about the mole of MgOH2? Well, we do have mass right here, right? And we can easily change that to mole. So that will be 25 grams times 1 mole over 58 grams, because that's the molar mass of magnesium hydroxide. And that will give you 0.43 mole. Okay? So there you go. Sub it in right here. 0.43 mole. So the concentration is going to be 0.172 in molarity. All right, so that is the concentration of the solution after adding in 25 grams of MgOH2 and dissolve it in 2.5 liters of water. Now, as you can see, we made a little prediction here. We're predicting or assuming that 25 grams added will not change the volume. But if you think about it, in reality, it does. But if you were to take that into account, we need to multiply this by the density to find volume or something. I don't know, something like that. So ignore that fact. That's not going to change it that much. So volume remained the same. So here's the concentration. All right. So let's go back here then. So if the concentration of this is 0.172 m, what would this be? Well, the ratio was 1 to 2, right? That means this is going to be 0.172 times 2. That means 0.344. Why do we need that? Why do we need to know the concentration of OH? Well, that's because if you want to find the pH of a base, you need to first find pOH. pOH is equal to the negative log of OH concentration. All right, let's take a look at what that is. Negative log of 0.344. Well, that's going to give you 0.46. Now, how do we find pH? pH is equal to 14 minus 0.46. Hey, that is 13.54. bad, isn't it? Not bad at all. So a little bit more work. So whenever you're trying to find pH of base, there's a little bit more work than finding the pH of acid. Especially the fact that in base, the ratio of the base and OH is not always 1 to 1. As you can see, this one is 1 to 2. Okay, let's continue on. Let's take a look at the part B of this question. So part B of the question says, the above solution, which is this solution with this concentration, you're going to add water to it. And you're going to make sure that the final volume is 3.5. Haha, you're diluting again. Find pH. So let's draw this out. So you have your solution right here of MgOH2. There's 2.5 liters of it. And from part A, we know that this is 0.172 in molarity. That's nice. That's nice. And we are going to turn this. Let's draw a bigger beaker. Same molarity, but 3.5 liters. What is the concentration? Eventually, what is the pH? So what we know is that we added water here. So again, this is another dilution question. C1V1 equals to C2V2. All right, C1 is 0.172. V1 is 2.5. C2 is what we want to find, and V2 is 3.5. So C2 must be quickly calculate that. So 0.172 times 2.5 divided by 3.5, and that will be 0.123. All right, so concentration obviously is lower because you added water. Okay, time to find pH. If you remember correctly, you can't find pH yet, or at least pOH yet, because this is this guy, not this guy. So first, we have to multiply that by 2. So let's just do it in our pOH expression. So that will be negative log of 0.123 times 2. Okay? And that is going to be 0.61. So that means pH is equal to 14 minus 0.61. And your answer is 13.39. Hey, whenever you finish a question, again, you should always ask yourself, does this make sense? Because before adding water, it was 13.54. After adding water, you are moving away from 14. You are moving closer to 7. That means you're being less basic. And that is right, because that's exactly how it is. So these are very simple questions that I think is a must that you know how to do. You know, dilution to get over, the final pH. This is also dilution to get the final pH of a base. So let's take a look at some, I guess, more challenging questions. I wouldn't say they're challenging. I would say that they are a little different. They're a little bit more interesting, that's for sure. So let's take a look at this situation. Let's take a look at this question. So I have a solution right here. Okay, let me use an easier base like NaOH. Now, do you know why this is an easier base? It's because one of these yield only one of these. Because NaOH will dissociate to give you Na plus NOH minus. And as you can see, the ratio here is 1 to 1. Meaning that whatever the concentration of this is the same thing as the concentration of that. Hey, just like acid. So let's take a look at this question. So I have 0.5 molar of NaOH at, let's say, 2 liters. And guess what? I'm going to drop 10 grams of NaOH in there. Hey, we haven't seen this yet, huh? We're not diluting this time. No, we're not diluting. I'm not adding any more water in there. What I'm adding is more solute. So if anything, I'm making this more concentrated. I'm raising, well, in this case, yeah, raising the pH. Because this is a base. Remember, there's a difference between raising pH of an acid, which means making it less acidic. But if you're raising the pH of a base, you're making it more basic. Kind of confusing sometimes, but hey, you'll get the hang of it. So, my question is this. What is the pH after the addition of 10 grams of NaOH? Well, before you find pH, you need to find concentration. So the concentration of this situation is that you need to total the mole divided by the volume. Again, making the assumption that this will not affect this. All right, so volume is going to be 2 liters. So what would the total mole be? Well, let's take a look at how many mole is in here to begin with. So you have 2 liters, and you have 0.5 moles per liter. Well, the amount of mole is 1. So we know there's 1 mole already inside the beaker. The question is, how many mole is here? Well, let's do our calculation. So 10 grams times 1 mole over 40 grams. That's the molar mass. So the answer here, of course, is 0.4 mole. So you have 1 mole already in here, and you're really adding 0.4 mole. So there you go. Let's make that happen. So the answer here is 1.4 divided by 2. So that is 0.7 in molarity. Okay. So time to do pH. So pOH is equal to negative log of 0.7. Now remember, how come I didn't multiply anything here? I didn't do that last time. Well, because this is NaOH. Remember? One of these yield just one of these. So negative log of 0.7 is 0.155. So the pH is going to be 14 minus 0.155. That will give me 13.85. That is the pH for the final, I guess, part. And after adding 10 grams of NaOH. I'm sure before you add this in, this number was supposed to be lower. Now it's becoming more basic. Okay? All right. Hey, let's take a look at another question. I have right here a beaker of HCl. Hey, let's do some acid. That sounds kind of strange. Here's another beaker of acid. This is 0.5 molar at 2 liter. Just like before. This is 0.8 molar at 3 liters. So I'm going to dump them both into this bigger beaker. My question is, what is the new pH. What is the overall pH? Well, same drill. You want to find pH? Find the concentration. To do this, you're going to find the total number of mole divided by the total number of volume. Now, volume is easy. That is just 2 liters plus 3 liters. Mole? I don't think that's hard at all. So let's take a look at how many mole is in here. Now, we did this calculation already in the above example. So we know that this is 1 mole. Okay, so we know it's 1 mole. How much is in here? Well, there's 3 liters and there's 0.8 moles per liter. So this is going to be 2.4 mole. So add 2.4 mole. All right. What would this be? So that's 3.4 divided by 5. The answer is 0.68 molarity. Now, again, ask yourself, does this make sense? It should. Because if you're combining these two solutions together, the concentration must be between here and here. Well, it's going to be more towards here because there's more of this than that. So 0.68, hey, totally legitimate. Now, pH time. Hey, this is an acid. Hey, when it comes to acid, no pOH, directly to pH, just negative log this number, and you are good. So let's see what that is. Negative log of 0.68 is going to be 0.17. Hopefully this is not something difficult and you can easily follow. Okay, let's do another example. I have 2 more examples that I really want to check out, So let's take a look at this one. Oh, this one is nice, man. I love this example. Why? Because it's real. I have a beaker of HCl that has a pH of, let's say, 1.0. And the volume here is 2 liters, okay? And I want you to change this. There's a reason why this beaker is so much bigger. To pH 1.6. The question is, what are you going to do? Well, if you look at this question, you should ask yourself a couple of things. This is an acid, right? pH went up. So that means this is getting less acidic. How do you make something less acidic? Well, we've seen an example up above. You add water to make things less acidic. You're going to dilute it. But of course, the question here is how much water you're going to add to get from here to here. That's a cool question. So since you're adding water, this is nothing more than another dilution question. First, to solve this, you might not want to look at this as a pH. Maybe you want to change this to concentration and change that to concentration. This will be original concentration. This will be final concentration. So let's change those pH into concentration. So HCl concentration is really equal to H3O plus. And to change pH to concentration, you take 10 to the power of negative pH. All right. What would that be? 10 to the power of negative 1. That will be 0.1. So the original concentration is 0.1 molar. let's take a look at here. HCl is equal to 10 to the power of negative 1.6. Okay, so 10 to the power of negative 1.6, that will be 0.025. So, hey, this is my C1, this is my C2. Now, I do have V1. Guess what? I can easily find V2. Because by finding V2 and comparing it to V1, I know exactly how much water I put in. This is so sick. So, let's do my dilution equation. Let's plug in those numbers. So, I have 0.1 molar. I have 2 liters equal to 0.025 molar. And what is V2? So let me calculate this for you. Times 2 divided by 0.025. And my answer exactly is 8. Wow. I can't believe I actually got an integer as an answer. It's unprecedented, huh? So the final volume here is 8 liters. Of course, I did not answer my question yet. My question is, what are you going to do? So the final volume is 8 liters, and you started with 2 liters. I know exactly how much water I add, because all you have to do here is take 8 liters minus 2 liters, and the answer is 6 liters. So I added 6 liters of water. This is a good question, because somebody later on is probably going to give you a solution with a certain pH and tell you to adjust that. And this is how you would adjust it if you're looking at a dilution. Well, can you also make things concentrated? Absolutely. So let's take a look at this scenario. So I have right here NaOH. Okay, and this thing has a pH of, let's say, 13.5, and there is 2 liters of it, I guess. And if I want you to change this, still NaOH, but the pH here is going to be 14. Wow. How are you going to do that? Now, I'm going to keep the volume the same. I'm not going to play around with the volume. Again, we're going to make an assumption that the volume, that whatever you add here doesn't change this. So how do I get from 13.5 to 14? Obviously, this is a base. By increasing the pH, I'm adding more solutes. I am adding more NaOH crystal. But the question, of course, is this question mark right here. How much? How much? Well, again, let's turn those pH into concentration. So the concentration here is this. Now, the good thing about this is that NaOH and OH is 1-to-1. That makes life actually a lot easier. But even if it's not something that you can't figure out, right? But in this question, since we're talking about a base, there is a little bit of things that you need to do first before you proceed. You need to turn this pH into a pOH. Why? Because by taking 10 to the power of negative pOH to get OH concentration, this has to be pOH. So let's find the pOH first. Okay, so pOH is going to be 14 minus 13.5, so that is 0.5. Right here, pOH is 14 minus 14, so it's going to be 0. Okay. I hope this doesn't give me a problem. I'm pretty sure it doesn't. So OH is going to be 10 to the power of negative 0.5. Okay, so 10 to the power of 0.5. Sorry, negative 0.5. So I almost made a mistake there. It's going to be 0.316. Okay, so right here, NaOH is equal to OH minus, so 10 to the 0. There's no such thing as negative 0. That will be absurd if you think about it. And the answer here is 1. Okay. POH is 0, so OH is 1. You won. You can check. Negative log of zeros, of course, is pretty much undefined. It's really, really, really strange. All right. Now, obviously, you're making things more concentrated here. So you're not going to use no dilution formula because that will be really, really weird. So instead, you're going to find out how many mole is in here and how many mole is in here. To do that, it's simple. Because we do have volume, 0.316 mole per liter times 2 liters. Okay. That will be 0.632 mole. So inside this beaker, there is 0.632 mole of NaOH. All right. If I want to make it a pH 14, that means I have to take 1 molar times 2 liter. So the amount of mole here is 2 mole. Right. So what I'm trying to say here is that this is 0.632 mole of NaOH. What I want is to add NaOH to make it 2 mole in here. So how much do I add? Well, that's pretty simple. Take the difference of the final and the initial. So 2 minus 0.632 is 1.368. So you're going to add this amount in here. But does that sound ridiculous? When have you ever asked people, hey, drop 5 mole in here? No. You drop 5 gram in here. So to finish this question, you might want to convert mole to mass by multiplying it by the molar mass of NaOH, which is 40. I hope it's 40. Okay. And your final answer here is 54.72 grams. So this is how much you're going to add in here to change the pH from 13.5 to 14, because you are making it more basic, more concentrated, and hopefully you understand the steps that we have taken here. Anyway, I hope you get it. Goodbye now.